Assalamualaikum and salam sejahtera. My name is Muhammad ZAHIN KHALIS bin AWANG ID with metric number 2012911086. Today I would like to talk about the introduction of electric flux density. First, density is a type of measurement that exists everywhere, whether on a physical object or non-physical. In some physical properties, it is a measure of the quantity of an object's mass per unit length, area, and even volume. The density of most non-physical substances, particularly such as gases that known as air, the density increases when the pressure or the temperature falls. In terms of electromagnetic radiation, the quantity of energy per unit volume in a region of space or substance is referred to as energy density. And electric flux density is described as the quantity of flux or charges passing through unit surface area or a certain material as the charge leaving out of the surface. Next is Faraday has found that there was some form of displacement occur where the charges within the inner sphere migrated towards the outer sphere, which was independent despite the material used as a dielectric material. And he named the occurrence as the displacement flux, which he said that the displacement flux is identical to the charges contained within the inner sphere. And if the displacement flux is calculated over the surface area of the sphere, which is 4 pi r squared, we will get the vector quantity of flux line as it is leaving out of the surface of the sphere, and it is popularly known as electric flux density. Faraday concludes that the total charge of the outer sphere is identical in terms of magnitude to the initial charges supplied on the inner sphere. That's all from me. Thank you.
Assalamualaikum. Today I will present to you about a review of concept for my team, group 4 for electric flux density. So here we have three things I will present to you. It is a concept of electric flux density, 3.1 Faraday's experiment, 3.2 electric flux density equations. So we will start with the concept of electric flux. So the concept of electric flux density is electric field generated by a free electric charge is measured by the number of electric lines. So the permittivity of the substance through which the electric field flows is multiplied by the electric field strength. So the unit for this electric flux density is coulomb per square meter. Another name for this flux density is electric displacement. Others call it electric displacement rather than electric flux density. So it is also independent of a relative permittivity of a dielectric medium. So this is the concept of electric flux density. So next we will go for a Faraday's experiment. This Faraday's experiment is here by Michael Faraday and conducted by the Michael Faraday. And Michael Faraday said that this experiment is a concentrate metallic spheres that could fit together tightly. So here have a outer sphere and we have a inner sphere. So the outside metallic was grounded to remove any stray from the outside. So in this inside metallic sphere was given to quantifiable the charge. Okay, so a charge on the outer sphere from radius b, this is radius b, was equal with a radius equal with charge on radius a in inner sphere. Okay, so this a charge in a is equal to charge in b. So the electric flux is a number of electric field lines from a charge that intersect a surface in the terms of streamlines, which also indicated the flow. So the charge of electric flux produced by the inner sphere will uniformly spread across the surface, and outer sphere will also goes the same way. So this inner sphere we never spread across the surface, and outer sphere also goes the same way like the inner sphere. So this is a Faraday's experiment. You can see this have a metal conductive spheres and salting all dielectric materials. Okay, we have charge here, we have charge. So this is a radius A, radius B. Okay, next we will go for electric flux density. Okay, I will use the Maxwell's equation. The unit is coulomb per meter square. So this is a unit vector, so it has a magnitude and direction. So I will tell to you guys about magnitude. Magnitude is a normal flux lines in coulombs that crossing surface normal to the lines will divide it with the surface area. So the direction is direction flux lines has the same direction with E. So you guys, if you guys learn about E, you guys know where's the direction because it has a same direction with the E. So for the equation, we have Q as a flux and we have 4 pi r square as an area. So for a point charge, we will see here is D. We have a flux over area. Okay, this is the equation. So this is the general equation. You guys will use this equation to find the flux density equation. So that's all from me. Assalamualaikum and thank you.
Hello, good evening. My name is Muhammad Akmal Hilmi bin Muhammad Azhar from Arwa 31. My metric number 201291089. Today, I would like to present about the history electric flux density. So this person is called Carl Friedrich Gauss. Gauss' law, which also we know as the theorem of Gauss flux, is a principle that specifies the relationship between electric charge distribution and the resulting electric field. This concept was invented by Carl Friedrich Gauss in 1835. The principles are able to be mathematically formulated using vector calculus in terms of integration and deviation, and the two of them are considered identical since the divergence theorem connects them. This pattern of the theorem may be characterized as a relationship between the quantity of charge and the electrical field, or as relationship between the displacement flux density, which nowadays is known as electric flux density, and the unconstrained charge enclosed within. So the next person is Michael Faraday. Michael Faraday found the displacement of charge between the two spheres in the experiment he conducted despite the type of electrical material were used to separate the sphere, and he named the process of charge displacement as displacement flux. His discovering magnetic induction in 1830. Then by calculating the displacement flux over the surface area of the sphere, he obtained the vector quantity of the flux line pointing outward, and it leaves the surface, and he called this method as the displacement flux density, which currently popularly now known as the electric flux density. That's all from me. Thank you.
Hi, my name is Mohd ZAHIN, index number 201291087. Now I will tell the relationship between electric field intensity and electric flux density. Electric field intensity can be defined as the force per unit charge at any point on the field region, while electric field density is defined as the electric charge over unit area of the spherical surface having its center at charge Q. From electric flux density, density is with respect to certain length, area, and volume. From Faraday experiment, the density can be calculated from the surface area of the sphere. We know the surface area of the sphere is given by the S equal to 4 pi r square, which is S is the surface area and R is the radius. Hence, the electric flux density is the total amount of electric flux generated which has crossed certain surface areas, so we can define as Q over 4 pi R square. Q is the amount of electric flux generated and 4 pi R square is the surface area. Electric flux are the line originated from positive charge and terminated at negative charge. They are directed, so electric flux density is also directed. We use AR hat as the unit vector. Electric flux is a charge, so electric flux density with respect to the surface area we using unit coulomb over meter square. Here we have electric field intensity which is E equal to Q over 4 pi epsilon 0 R square times AR hat in which unit V over meter. If we compare the formula, they're different only the epsilon naught. Hence, we find the relationship is D equal to epsilon naught E if the medium free space. In general, we can say that T equal to epsilon E or E equal to D over epsilon. That's all for me. Thank you.
Assalamualaikum. I will continue the last chapter of our assignment, which is conclusion. For the conclusion, overall we achieve our objective. The first one, we had done the research regarding electric flux density, which is the number of electric lines of force passing through a given area that corresponds to the strength of an electric field generated by a free electric charge. It is calculated by multiplying the electric field strength by the permittivity of the material through which is the electric field extends. The second one, we also had done explain and review the concept of electric flux density, which is the concept of flux describe how much something moves through a specific area. It is a dot product of vector field, in this case the electric field and an area. The flux of an electric field can be thought of as a count of the numbers of electric field lines that pass through a given area. Other than that, electric flux density was used in daily life, like inside electric motor, ductor, mechanical electric generator, and etc. Furthermore, the generator somewhere in the grid most likely use electric flux to produce the voltage we use now, which is like a three-phase 415 volt AC, like a single phase 240 volt AC. Lastly, the Gauss law was applied in the electric flux density, which is the flux through a closed surface equals the total charge enclosed within the closed surface divided by the vacuum permittivity. That's all from me. Thank you.